Hello friends, welcome to all of you in Dr. Jaggi's Academy. In this lecture, we will discuss about the isomerism. So first of all, we'll start with what are the isomers. So isomers, two or more compounds having same molecular formula but different physical and chemical properties. These compounds which have same molecular formula but different physical and chemical properties, they are known as isomers. And the phenomena is known as isomerism. So let's start. Why the different compounds having different physical and chemical properties? This is due to two reasons. Number one is due to different arrangement of atom or group within a molecule. The second reason for different physical and chemical properties due to different arrangement of atom or group of atom in a space. So when the difference is due to the arrangement of atom or group within a molecule, then the isomers are known as structure isomers. Or we can also say that constitutional isomers. So structure isomers are those two or more compounds in which having the same molecular formula but different structural arrangement of atom or group of atom. On the other hand, when there is a difference between the arrangement of atom or group of atom in space, then these compounds are known as stereoisomers. So stereoisomers are two or more compounds having same molecular formula but different arrangement of atom or group of atom in space. So let's take example. So we have a two compound. The one is acetone and second is propanol. So in this case, these two compounds having the same molecular formula, that is C3H6O. But due to arrangement of atom, they show different physical and chemical properties. In the first compound, here we have a ketone as a functional group. In a second compound, we have a aldehyde as a functional group. So this compound shows the properties of ketone, and this compound show the properties of aldehyde. So it means these two compounds show different physical and chemical properties. So these are the isomers. There is a difference between the structural arrangement in a molecule. So that is why these two are the structural isomers. The second example, that is we have a butane. So in a first case, CH3, CH2, CH3, CH2 and CH3. But in second case, we have a chain, parent chain containing 3 carbon atoms and 1 carbon atom is present in a branching state. So these two compounds, they having the same molecular formula, that is C4H10, but they show the different properties. This compound is named as normal butane and this compound is named as 2-methyl propane. So these two compounds are different compounds having different physical and chemical properties but having the same molecular formula. So these two are the structural isomers. First of all, we will discuss about the structural isomerism. It means structural isomers. So what are the structural isomers? Structural isomers are the compounds in having the same molecular formula but different structural arrangement of atoms or group of atom in a molecule. So structural arrangement of atom or group of atom is due to the 5 reasons. Number 1 is it may be differ in the number of carbon atom in a parent chain. Means due to difference in the number of carbon atom in a parent chain, the compound show different structural arrangement, means they show different physical and chemical properties. So that compounds are known as chain isomers and this phenomena is known as chain isomerism. To explain it, I am taking the example of that is butane. So we have a two compound. The first compound is normal butane and second one compound is 2-methyl propane. These two compounds have same molecular formula, that is C4H10, but they have a different structural arrangement. So due to difference in structure arrangement, they show different physical and chemical property. It means these two are the chain isomers. Chain isomers because these in the first compound there is a 4 carbon atom in a parent chain. But in second case the number of carbon atom in a parent chain is 3. Whereas fourth carbon is attached to this parent chain in a branch form. So these two compound are different due to different in the number of carbon atom in a parent chain. It means these two compounds are chain isomers, and this phenomena is known as chain isomerism. The different structure arrangement of atom or group of atom in a molecule is due to difference in the position of functional group or multiple bond in a molecule. When two or more compound, they are different due to different in the position of functional group or multiple bond in a molecule, that these compounds are known as position isomers. And this phenomena is known as position isomerism. So to illustrate this position isomerism, I am taking the example of butene, whose molecular formula is C4H8. This C4H8 we can write in two ways. Number one is that is a 1-butene and this one is 2-butene. In this case, the double bond is attached to first carbon atom, but in second case, double bond is attached to the in this case double bond is attached to first carbon atom, and in this case double bond is attached to second carbon atom. The number of carbon atom in a parent chain there remains same. So these are not chain isomerism. These are the position isomerism because these two compounds are different due to differ in the position of functional group or multiple bond in a molecule. So these are the position isomers. Third difference, the structure arrangement of atom or group of atom is due to differ in the functional group. Means two or more compound having the same molecular formula but different function group. So due to different function group, they show different physical and chemical properties. So that compounds are known as functional isomers, and this phenomena is known as functional isomerism. To explain it, I am taking the example of these two compounds. These two compounds having the same molecular formula, that is C3H6O. It means these two compounds contain 3 carbon atom, 6 hydrogen atom and 1 oxygen atom. But these two compounds are different due to different functional group. Number one is in this compound, this compound contains aldehyde function group and this compound contains ketone function group. Due to presence of this aldehyde, this compound show the aldehyde properties and this compound show the ketone properties. It means they show different physical and chemical arrangement. Physical and chemical properties. But the molecular formula is same. So due to difference in the functional group, these isomers are functional isomers. And this phenomena is known as functional isomerism. The fourth one is different structure arrangement of atom or group of atom in molecule is due to different in the number of alkyl group present on the either side of the functional group. It means functional group remain the same, number of carbon atom in a parent chain remains same, but number of alkyl group around the functional group that are different. So that compounds are known as meta-isomerism. And this phenomena is known as meta-isomerism. To illustrate it, I am taking the example of these compounds having molecular formula C4H10O. So in both the compound contain same functional group, that is the ether. So this compound is diethyl ether or this one is methyl propyl ether. So in this case, this is the function group. So in this case, one ethyl group present on this side and one ethyl group on this side. But in second case, the methyl group is present, one methyl group is present on this side, that is a left side of the ether, a functional group, and propyl group present on the other side of the ether. It means these two compounds are different. Due to different of alkyl group, they are present on the either side of this ether group. So these two compounds are known as meta-isomers, and this phenomena is known as meta-isomerism. The fifth difference, structural arrangement of atom or group of atom, is due to the difference in the arrangement of atom, but they exist in equilibrium with each other. So these isomers are known as tautomerism. So to illustrate it, I am taking the example of acetone and enol. So here we have acetone CH3COCH3. This compound, they exist in equilibrium with the enol. So how does it actually take place? As we know that oxygen is more electron withdrawing effect. So it withdraws the electron toward itself. As a result, this carbon acquires a positive charge. So to compensate the positive charge, this carbon has a tendency to attract the sigma electron from the alpha carbon. So this attract the sigma electron toward itself. As a result, the hydrogen H positive, they move toward this oxygen. So there is a formation of enol. Means why we call as the enol? Because there is a presence of E means double bond, ol means alcohol. So this compound contain two things. Number one is double bond and second one is ol. So these two compounds, they exist in a dynamic equilibrium with each other. So, but there is a difference in the arrangement of atom having the same molecular formula. So these two compounds are known as tautoisomers, and this phenomena is known as tautoisomerism. So it means the structural arrangement of atom or group of atom in a molecule, they are different due to a different 5 things. So it means structural isomers, there are 5 types. Number 1 is chain isomers, second is position isomers, third one is functional, fourth is meta, and fifth one is tautomerism. So these isomers are different due to differ in the position of either number of carbon atom in a molecule, either in a position of functional group, nature of functional group difference in the number of alkyl group around the functional group, or difference in the arrangement of atom, but the compounds, they exist equilibrium with each other. So we have 5 types of structural isomers.